Good morning, all of you.
Good morning, Miss.
Shall we start? If you have joined. Okay, answer your attendance. Afla, Ajmina, Amaya,
Present, Miss.
Atulya, Drishya,
Present, Miss.
Jyotish, Karthik, Kavya,
Present, Miss.
Nachiket, Neeraj,
Miss.
Ranjit,
Miss.
Vaishnav,
Present, Miss.
Anjali,
Present, Miss.
and Shruti.
Present, Miss.
Okay. Anjali is there?
Ma'am, yes.
Okay. So Afla is there? Afla, Ajmina, Atulya, then Jyotish,
Present, Miss.
okay. Karthik, then Nachiket,
Present, Miss.
okay. Vaishna and Anjali. Anjali has joined. Okay. Okay, we will start the class. Now, yesterday we have seen the type of a data link protocol that is called as the high-level data link control protocol. Usually, that is a bit-oriented protocol, and that is used for point-to-point and multi-point links, where it supports half duplex as well as full duplex configuration. And you have seen what are the different types of modes of communication in an HDLC protocol, what are the different station types, and what are the configuration available. Now, what are the three different station types in an HDLC protocol? Can anybody answer? What are the different stations?
Primary, secondary, combined.
Yeah, primary, secondary, and combined. And what are the different types of configuration available? What are the different types?
Balanced,
Yeah, balanced,
unbalanced, symmetrical.
unbalanced, and
Symmetrical.
unbalanced, and
Symmetrical.
yeah, symmetrical. Now, what are the different modes of communication in an HDLC protocol? You can have two modes. One is the normal response mode. Other one is the asynchronous balance mode. Okay. Now, today we will be dealing with another function of data link layer that is called it as the error detection. I hope you can see the slides. This is one of the function of data link layer that is called error detection. Now, whenever you are considering a network, it must be able to transfer the data from one device to another device with complete accuracy. Whenever you are considering a network, it must be able to transfer data from one node to another node with complete accuracy. But sometimes this data may get transferred. Sometimes error may happen during transmission. Okay, so in order to have a reliable communication, what you have to do is you should be able to detect the errors as well as you have to correct it. So for reliable communication to happen, the errors must be detected and corrected. Okay, now this error detection and correction, usually it is done in the two layers of the OSI model as well as the TCP model. That is the error, one is the data link layer and another one is the transport layer. So if you are considering these two layers, the two processes being, that is, the error detection as well as the correction is done by the data link layer as well as the transport layer. Okay, so During transmission, errors may happen, and that errors must be detected and corrected. And that is the function of data link layer as well as the transport layer. Now we will see what are the different types of errors in a net. I mean, during transmission, what are the different types of errors that can occur? So errors can be classified into two types. One is called it as the single bit error. The other one is called it as the burst error. I repeat, errors can be classified into two. One is called it as the single bit error, and the other one is called it as the burst error. So now what is this single bit error? Now I told all these errors, they happen, I mean, that is due to some interference it can happen. So interference means you are changing the shape of the signal. The signal changes, I mean, the shape of the signal gets changed during the transmission. So, and I told you have got two different types of errors. One is single bit and other one is the burst error. Now, what is this single bit error? Single bit means only one bit in the data unit has changed. Only one bit in the data unit has changed. The meaning is either 0 is changing to 1 or 1 is changing to 0. That is called it as the single bit error. You can just see in the diagram. See the send frame. You are having 6 zeros, 1 and 0. But what you have received is there is an error in 1 bit. So that is 0 is changed to 1 or 1 changes to 0. That type of error, you can call it as a single bit error. Okay. Now, the other type of error, you can call it as the burst error. Burst error means 2 or more bits in the data unit have changed. Burst error means 2 or more bits in the data unit have changed. The meaning is, as an example, consider this data that is sent and received. You can just see what is the sent bits and what is the received bits. So you can see 0 is changing to 1, 0 is changing to 1, again 0 changes to 1 and 0 changes to 1. So more than 1 bit has got an error. So such type of error is called it as burst error. Now, what is the length of the burst? How you are determining the length of the burst is from the starting towards the ending. Now, in the middle, maybe the bits may get reach correctly, but that is not the case. From the starting bit where the error happens to the ending bit where the error happens, that is the total length of the burst error. So here, as in this example, the length of burst error will be of 8 bits. Okay, understood? What are the two different? This is another example for burst error of length 5. So you can see 0 changes to 1, again 0 changes to 1 and 0 changes to 1. So the bits are corrupted here. So what is the length total? The starting bit, it is this, and to the ending, to total 5 bits are there. So the length burst error of length 5 is shown in the diagram. Okay, so now how can we detect and correct these errors? Now you have to correct these errors, either a single bit error or a burst error. You have to correct these errors. Now, what is the technique that is used to correct or detect an error? The first you have to detect it, then only you are able to correct it. Now, in your syllabus, you have to study about only error detection and not correction. Okay. Now, how errors can be detected? Errors can be detected if, in order to do that, we need to send some extra bits along with the data. So error detection uses the concept of redundancy. Redundancy means you are making use of some extra bits, and that extra bits is attached along with the data and sending. At the receiver side, you will have a checking function and you will see whether error happens or not. Okay, so the redundancy bits, some extra bits, you can call it as the redundant bits, that is transmitted along with the data. Now, how does this function? So you can just see in the diagram, see you are having a data you will be having a generating function where it will generate the redundancy bits, and you will be attaching the redundancy bits along with the data. You will be transmitting it through the medium. At the receiver side, you will be having a checking function. If the received bit stream, if it passes the checking function, now the data portion is accepted, otherwise it is rejected. That is the concept, how the working principle of how you can detect the errors with redundant bits. So the concept is the redundant bits are used to check the accuracy of the data unit. So the data unit, it may be passing through a device. It will analyze that and it will add some. So you will be having some redundancy bits you will be getting. Now the data unit along with the redundancy check is transmitted through the medium, or it is sent to the receiver, and the receiver puts the entire stream to a checking function. Okay, now if the received bit stream, if it passes the checking function, the data unit is accepted, otherwise it is rejected. That is the concept of error, like with redundancy bits, how you are able to detect the errors. Okay, so I have told errors, data may get changed during transmission. Okay, so in order to have a reliable communication, errors must be detected as well as corrected. Now, errors can be detected. Two types of errors you have got. One is called the single bit error, other one is called the burst error. Single bit means only one bit has changed. Burst error means two or more bits have changed, that is called it as burst error. Now, if I want to detect the error, what I have to do is I have to attach some redundancy bits or some extra bits along with the data. That will be attaching. Receiver side, you will have a checking function. If the received bit stream, if it passes the checking function, the data is accepted, otherwise it is rejected. Understood this much? Okay. Now you are going to see what are the different error detection methods. What are the different error detection methods? Now you can have 4 categories of detection methods. One is called it as the VRC, vertical redundancy check. Second one is LRC, that is longitudinal redundancy check. Next one is CRC, cyclic redundancy check. And the last one is the checksum. In your syllabus, you have to study the last 2, that is the cyclic redundancy check and the checksum. Okay, so you have 4 categories. The important ones, or the most powerful one, is the CRC method. And another detection method also you have got, that is called it as the checksum. Now, what is this CRC? CRC or cyclic redundancy check. Now, cyclic redundancy check is the most powerful redundancy checking technique, and that is based on binary division. I hope you all know binary division. So CRC method is the most powerful error detection technique, which is based on binary division. Now, what is the concept behind this? You will be having the data, you will be dividing it with your divisor, and you will be obtaining a remainder. And that is called it as the redundancy bit, CRC remainder. That is called it as the remainder bits or the redundancy bits. Now, what you will do is you will attach that CRC along with the data. Now, at the receiver side, the data as well as the CRC, again, it will be divided by the divisor and you will be obtaining a remainder. Now, if the remainder is 0, you assume that there is no error during transmission. You will accept the data. And if it is not 0, now some error has happened, you will be rejecting that. That is the simple concept of this CRC checking detection method. Okay, so sender part, you will be generating the CRC, and at the receiver side, you will be checking that. So it is CRC generator and checker. You will be generating the remainder bits. Now after that, you will be attaching along with the data, and finally at the receiver side, you will be checking it. Okay, so CRC is the most powerful redundancy checking technique that is based on binary division. So you will be obtaining a redundant bits that is called it as the CRC remainder, and that is added along with the data that is transmitted, and this at the receiver, the arrived data, it is divided by the divisor again, and you will be obtaining a remainder. And if it is 0, you will be accepting the data. If it is not 0, you will be rejecting the data. Okay, now what are the actions taking place at the sender side? Now look on to the sender part. Sender part, what you are doing is 3 steps are involved in the sender side. First step is you are going to append n zeros along with the data unit. The first step is you are going to append n zeros that is based on the divisor bits. If the divisor is of n plus 1 bits, if total 4 bits are there, you will be attaching n minus 1. Okay, you will be attaching n bits, means 4 bits means 3 bits, 3 zeros you will be added along with the data. Okay, so the number n will be 1 less than the predetermined divisor, which is nothing but the n plus 1 bits. Understanding what is the first step that is acting in a CRC deduction method? First step is you have to append zeros along with the data unit. And the number of zeros you have to append is 1 less than the number of bits in the predetermined divisor. The divisor already you know, and that you will count the total number of bits, and the number of zeros should be 1 less than the divisor bits. Okay, now the second step is the newly elongated data unit is divided by the divisor. You are making use of a process called binary division. You will be just go on dividing and you will be obtaining a remainder. Okay, now the remainder is called it as the redundant bits or the CRC, cyclic redundancy check bits. Okay, now the third step is this CRC of n bits, which is derived in the previous step. It replaces the appended zeros of the data. So here zeros you are attaching. So instead of that zeros, what you will be attaching? The CRC what you are generated. So that will be transmitted. Okay. Now what happens at the receiver side? A checker function is there. So that is exactly similar to that of the generator. Now after receiving the data at the receiver side, it does the same binary division process. So once it is done, if the remainder is all zeros, the CRC is dropped and the data is accepted. If it is not, otherwise it is discarded. Understood the concept of CRC generator and checker? Yes or no? What is the concept of CRC generator and checker? Can anybody answer?
Yes, miss.
Okay. So CRC generator happens at the center side and checking function, it happens at the receiver side. So you are having a data. First, you will be append zeros along with the data. You will divide it with the divisor. You will be obtaining a remainder. That is nothing but the CRC. You will replace that zeros with the CRC. You will transmit it at the receiver side. You will divide again with the divisor and you will see what is the remainder. If it is 0, there is no error. You will accept that data and discard that CRC. And if it is not 0, you will reject that. Okay, now this is just the next slide shows an example for CRC generator. So what all steps I have told, this is shown with an example. So I hope you can all see the slides. Just listen. I'm just seeing the diagram and explaining. So your data is 100,100. Okay, your data is 100,100. Now what is the first step? You have to append n zeros along with the data. It depends upon the divisor. Okay, now what is the divisor? It is 1101. So the total 4 bits you have got, you have to attach one less than that. So 3 zeros you have to append along with the data units. Now what you have to do, you have to just divide it with the divisor 1101. So here what is happening is binary division takes place. I hope you all know binary division. So just go on dividing, and in the end you will be obtaining a remainder. Okay, that remainder is 001. Here one step you have to just remember, when the leftmost bit of the remainder is 0, you must use 0000 instead of the original divisor. When you are go on dividing, if you are obtaining a remainder with the most significant bit as 0, then the next step what you have to do is you have to attach zeros and then go on dividing it. Okay, now finally once you divide it, you will be obtaining the remainder 001. And that is nothing but the cyclic redundancy check bit, that is the CRC. Excuse me. Okay. Now what happens at the receiver side? CRC checker, how it functions. So you are having the data, you obtain the CRC. Now what is the next step? You have to attach the CRC along with the data. So your data was 100100 and your CRC was 001. Okay, so CRC plus data, now you are transmitted. At the receiver side, you are going to check that. So again, you will be exactly dividing it with the divisor. And once you go on dividing it, you will be obtaining the result. So if the last, once you divide it completely, if you obtain the remainder as 0, what do you have to infer? There is no error during transmission. Okay, the data has come safely to the receiver side. So you will be accepting that data. Okay, so the data will be accepted, and the other, if it is not, it will be rejected. Okay, so that is the concept of CRC generator and checker. Now usually this CRC generator or the divisor is most often represented by a polynomial. Their example I have just shown with zeros and ones. You will have long strings of zeros and ones. So instead of that, what you will do is you will represent it in the form of a polynomial. Now, if you are representing in the form of polynomial, what is the advantage is it is short and you can use to prove it mathematically. Okay, so one is a polynomial way of representation. It is simple and also very effective one. And usually the CRC method and polynomial, the advantages mathematically you can find out the result, and also it is very compact. You don't have to add more number of zeros. Wherever zeros are there, you don't want to represent it with the variable. Okay. Now, this CRC method, it is very, very powerful technique. It is very effective technique. And now usually the CRC method is implemented in hardware. Okay, so the operation is very, very fast and expensive also. Now you are making use of two hardware components to do that. One is the shift register and the other one is the XOR gate. You might have studied in your digital electronics what is a shift register and what is an XOR gate. And these are the two hardware components that are used to do this cyclic redundancy check. Okay, now the next slide shows some standard polynomials used by the popular protocols for CRC generation. These are nothing but some standard polynomials you have got like CRC12, CRC16, CRC-ITUT, CRC32. They are nothing but it is a polynomial way of representation that is used by certain protocols. Okay, fixed one, the divisor part. Okay, so this is about the first type of error detection method that is called it as the cyclic redundancy check. Okay, understood. What is cyclic redundancy check? How the division process happens and how you are detecting the errors. Yes or no? Understood? Anjali? Afla is there?
Yes,
Okay. Ajmina? Atulya? Understood?
yes,
Okay. Then Karthik? Understood the concept CRC generator and checker? Yes or no? Karthik? Yes, okay. Now Vaishna is there? No. Okay. Okay, now we are going with the next detection method that is called it as the checksum. That is also a very easy one, checksum. So checksum is also an error detection method. Now, what are the steps involved in this checksum is you are having different steps. Now, the first step at the sender side, what happens here is if m-bit checksum is used, now the data unit to be transmitted is divided into segments of m bits. Now, what is the meaning is if you have a long strings of zeros and ones, now you are having a checksum. You are in the question, you will be getting the checksum, how many bits you are using it. So depending upon that, you will be dividing your data unit. Now, what you will do is these data units are added. That will be in strings of zeros and ones. So what you will do, all the m-bit segments will be added. Okay. Now, what you will do is once you obtain the result, the sum will be wrapped and complemented using ones complement arithmetic. This, whatever result you are obtaining as the sum. Now, if it is exceeding the total number of checksum bits, now what you will do is you will be wrapping it and then you will be complementing it. You are doing the ones complement. Now, the value what you are obtaining is nothing but the checksum. Okay, so the value that is obtained is called it as the checksum. So I repeat, you are having a checksum of n bits. You will have a data units, a long strings of zeros and ones. What you will do is depending upon your number of bits in the checksum, you will be dividing the data units. Now you will be adding all the data units. If the result is more than the total number of check bits, you will be wrapping it. You will be doing the complement and you will be obtaining a result, and that is called it as the checksum. Now what happens at the next step? Now the data along with the checksum value is transmitted to the receiver. So the data along with the checksum value is transmitted to the receiver. Now the receiver side, what you will do is if m-bit checksum is used, the received data unit is divided into segments of m bits again. Now all the m-bit segments are added along with the checksum value. You will be obtaining the checksum value at the sender side. Now that is attached along with the data. You will be adding all the things. If some value is wrapped, final result, if the more number of bits you are obtaining, you will be wrapping it, then you will be complementing and the result is checked. Now, if the result is 0, now what you have to do is you have to assume is if no error is there, if the result is 0, you have to assume no error during the transmission. The receiver accepts the data. Now, if the result is non-zero, the receiver assumes that error occurred in the data during transmission. So what it will do? It will discard the data and ask the sender for retransmission. Okay, I will just show with an example so you will better understand what is this. Now, suppose you are having a data. I hope you all can see the slides. You have a long strings of zeros and ones. Now, I am making use of an 8-bit checksum. If that is the case, what is the first step I told? You have to divide the data segments into the number of bits with the checksum. So here you have got 8. So what you will do? The 8 bits you will be dividing the data, starting from the LSB position. Okay, so you will be dividing it. Now what is the next step is you have to add all that data. So 100, 11001, the next data, and the next data bits you will be adding. The binary addition takes place. Now, once you add it and you will obtain a result. So here I have obtained the result as 10001000011. That is the total number of bits is more when I'm comparing with the checksum bits. If it was 8, you need to wrap it, but you have to complement it. But here you are obtaining 10 bits. So what I will do it in the next step is you will just wrap it. That is, the result consists of 10 bits, so extra 2 bits are wrapped around. Wrapped around means you are adding the bits along with the result again. So the result what I obtained is this one. I will be wrapping that 1 0 and you will be obtaining the result again. You will do the binary addition again and you will be obtaining the result. Now what I will do is I will take the ones complement of that data. So ones complement, what I obtained is 110, 110, 10. And that is nothing but the checksum value. Understanding? Divided the data, added it. I have checked whether additional bits are obtained. If no additional bits, you can directly take the ones complement. If additional bits are there, you have to wrap around it and then add it again. And that is nothing but takes the ones complement of that, and that is nothing but the checksum value. Okay, now at the receiver side, what happens? So receiver side, this checksum value is added again with the data unit. So you can see how the addition takes place. Now, once I added and once I get the result, again, an additional 2 bits I am obtaining in the result, I will wrap around it, I will add it with the data, and I will obtain the final result. After obtaining the final result, I will take the ones complement of that. Okay, I will obtain the ones complement. If the result is 0, I will accept the data, and if it is not, I will reject it. I will ask for retransmission. Understanding how the checksum works. Checksum, how many data units you will splitting it depending upon the checksum, what it is specified, then add it. If wrapping around takes place, if more number of bits are there, takes the ones complement, that is the checksum. The checksum along with the data is added along with the receiver. You will see the final result. If it is additional bits are there, again wrapping takes place. You will obtain the final result and you will take the complement of that. Now, if the complement value, if it is 0, you will assume that there is no error during transmission. You will accept that data. Okay, understood what is checksum? Now, all of you, I will be giving you a problem. All of you just do it in your book. Everybody have notebook with you? Yes or no? Yes, okay, take down. Take down the question. Suppose the following block of, suppose all of you has to write it and tell me the answer, what you are getting. Suppose the following block of 16 bits is to be sent. Suppose the following block of 16 bits is to be sent using a checksum of 8 bits. Using a checksum of 8 bits. Finish writing? Vaishnav? Yes, okay. Now take the data. Data is 1, 0, 1, 0, 1, 0, 0, 1. I repeat once again. The first bit data unit is 1, 0, 1, 0, 1, 0, 0, 1. Okay, now the next is 0, 0, 1, 1, 1, 0, 0, 1. The second block is 0, 0, 1, 1, 1, 0, 0, 1. Okay, so a long string of 16 bits you have got. Now, what is the first step you have to do? What is the first step you have to do? You have to identify what is the number of bits in the checksum. How many bits you have to use? Checksum is of how many bits? Jyotish?
8.
Okay, 8 bits. Now, what do you have to do?
8 bits.
Okay, 8 bits. Now, divide the data into 8 bits. Split it into 8 bits, the data unit. So, what you obtained? You are obtaining 1010, 1001 as one block, and the another block is 00111, 001. Okay, now what is the next step? What is the next step? You have to add it. Add it. Okay, add it and tell me what is the answer. Add it and give me the answer. It is binary addition. 1 plus 1 is 0 with a carry 1. Shruti? Yeah, answer. Tell me the answer. What is the sum you got? Make it fast. We have to complete it because it is almost time. So answer is, yeah, 111
0 0 0
0 0 0
1 0.
1 0. Okay. Now what is the total number of bits there?
8.
8 number of bits. So it is not exceeding the checksum. So no need of wrapping around. So directly takes the ones complement of that. Now all of you takes the ones complement of this sum what you have obtained. The sum is 111 0 0 0 1 0. So if you are taking the complement of that, you will be obtaining 0 0 0 1 1 1 0 1. Right? Yes or no?
Yes.
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 Now that is a checksum value. Write it. Checksum is equal to that value. Okay. Now at the receiver, what happens? Write it. Receiver. Your data, 2 blocks of 8 bits are there. You have to add this checksum value also along with the data. So totally 3 blocks of 8 bits. Add it and give me the answer. So who will be telling the answer first? They will be having a chocolate. When we meet personally, I will be giving it. Yes? Anybody want?
1 1 1 1 1.
Who told?
Afla.
Afla. Yeah, tell me, answer.
1 1 1 1 1 1 1 1.
Very good. The whole ones you are getting it. Now, what is the next step? You have to take the complement of that.
One.
Take the complement, one's complement. What you obtained? All
Zero,
zeros.
zero, zero,
Yeah,
zero.
8 bits are 0. So what is the meaning of that? If all bits are zeros, what is the meaning of that?
It is accepted.
There is no error. The data is accepted. Okay, others got the answer, all ones.
Yes.
Yes, Mr.
Yes, okay. So this is how the checksum functions. Okay, so additionally, if more than that, the confusion where it arises, if you are having, once you add it, you will be obtaining the sum. If more number of bits, what I shown in the example, you have to add it again with the result, then takes the ones complement. Okay, so that is the difference in that. Okay, so I will just wind up today's class. We have seen error detection method. Always you won't be tell that the network, the data will be receiving almost at the 100% accuracy. Errors may happen. So the errors must be detected and it should be corrected. So detection methods, you can have 2 types. Errors can have 2 types. One is single bit error, other one is the burst error. And error detection methods, 2 important methods you have seen. One is the cyclic redundancy check and the other one is the checksum method. Now how you have to find out the CRC generator as well as the checker. I have shown with an example and proved it. All of you, I'll be sending the slides today. Just go on dividing the division process. I mean, that CRC generator and checker, you have to just do it yourself and see what is happening and how are you getting the correct answer. Okay. So the other staff has joined. So let me wind up today. Thank you. And read the textbook today itself. Okay. Thank you.